If you shuffle your feet on the floor and touch something metal, you might feel a spark. If you rub a balloon on your shirt, it might stick to you. What is the invisible property behind these phenomena? It's electric charge. With PASCO's wireless charge sensor, you can investigate the polarity and magnitude of charged objects. The wireless charge sensor comes with a BNC to alligator clip cable for connecting to devices such as the Faraday Ice Pail, and an E-field probe for detecting the relative strength and polarity of nearby objects. The sensor actually measures electric potential in volts, but unlike a typical voltmeter, it has an extremely high input impedance, so virtually no current flows through it. Let's look at how we can use the charge sensor with a Faraday Ice Pail to investigate charged objects. I'll use the BNC cable to connect the sensor to the ice pail and to the shield surrounding it. I've already connected the sensor to capstone via Bluetooth and created a meter display to show the voltage measurement. You could also use SparkView software. When I lower a charged object into the ice pail, it will polarize the ice pail, resulting in a potential that the sensor will measure. I'll use this cable to momentarily ground the ice pail to make sure it's electrically neutral. And I'll click the 0 button in capstone to offset any stray charge that may have accumulated anywhere else. Now we're collecting data. If I put my hand into the ice pail without touching it, you can see it has no effect, but if I shuffle my feet on the floor, we see the charge on my hand change. We can do a more quantitative investigation with these charge producers. I've got 2 insulators here which are of different materials. As I lower each one into the ice pail, we can see they have little effect. But if I rub them together and repeat the measurement, now we can see this one is positively charged and the other one is negatively charged. But if we put them both in together as a pair, they remain neutral, showing that charge was conserved. The charge lost by one was gained by the other. The backs of these discs are conductive. Let's see what happens if we touch them together like this. And now they are neutral again. Let's try it again and see if we can charge them more with more vigorous rubbing. This one registers about 1.1 volts, and I predict this one will register about negative 1.1 volts. And indeed it does. Now let's see what we can do with the E-field probe. Here's the balloon. Let's test it. It's negative. I'll rub it with my hand. And now it's positive. And if I rub it with this wool fabric, it's negative again. I'll leave it up to you to figure out why. Visit the Wireless Charge Sensor product page on PASCO.com for more information about the sensor and related products like the Faraday Ice Pail and charge producers. And check out PASCO's experiment library for activities you can complete with the wireless charge sensor, like an investigation into charging objects by friction, by contact, and by induction. Thanks for watching.